So we're doing chapters 2.3 and 2.4. Um, Chapter 2.3, and we're moving on from numerical variables to categorical variables. Now, categorical variables, how we visualize them, and the use of bar charts, and pie graphs to visualize categorical data. Now, I've highlighted some things on the notes here that you can look at. We treat categorical variables very similar to numerical variables. However, a bar chart is used for categorical data. Similar to a histogram, the bar chart records data categories along the horizontal axis with the height corresponding to the frequency of the data. So here's an example of a bar chart. On this bar chart, we're looking at class standing for students in UCLA students interested in a statistics class. And what it does is that it takes the percentage, for example, for the graduate, that 0.05 of 20 would represent, the total of 20 would represent the relative frequency of 1. Which is that 1 right there. And say for unknown, that would be, say, about 0.35, 0.35 times 20 would give you about 7, and so on. So each of these bars represent the relative frequency of the categorical data shown in this table on the left-hand side. Now, differences between a bar chart and a histogram. In a bar chart, in a histogram, the bars may touch, and the bar chart, they do not touch. In a histogram, the bar width corresponds to the bin width, and a bar chart can be any desired width. They're all the same, it doesn't matter. In a histogram, we're dealing with numerical order. In a bar chart, there's no order, no inherent order. Now, that brings me to a definition of a Pareto chart. A Pareto chart is a bar chart in which bars are arranged from tallest to shortest. This cannot necessarily be done with a histogram. So if I were to take the data on this bar chart and put it from the tallest to the shortest set of data, then I would have a Pareto chart, okay? Arranged from tallest to shortest, not the other way around. A pie chart is a circle that divides into pieces. The area of each piece of that pie is proportional to the relative frequency or percent of the data in that piece. So here is the same example using a pie chart. And this is all proportions. For example, unknown would be 7 out of 20%. Sophomores would be 3 out of 20. Juniors would be 4 out of 20. Seniors would be 5 out of 20. And graduate 1 out of 20. Now, chapter 2.4, very brief, we're talking about the mode and variability in categorical distribution and describing categorical distributions. So, to describe a numerical distribution, remember that we used shape, center, and spread. Since the categorical data does not have an inherent order, this would not make sense for categorical data. So instead, we use two components to describe categorical data: mode, the typical or the most frequent outcome, and the variability or the diversity in the outcomes. The mode, the category that occurs the most frequently. And notice, in numerical data, the mounds do not need to be the same height. In categorical data, big difference here, the modes must be roughly the same height. We use the same type of descriptions as before. Unimodal will describe one mode, one distinct mode; bimodal, two modes; and multimodal modals, anything more than two modes. So here's an example. In 2012, the Pew survey asked a group of 2,508 Americans which economic class they identified with. And this is by percentage here, where we have about 1% didn't know, about 30% were lower class, about 49% were middle, and about 15% upper class. Remember, this has to add up to 100. That those percentages must add up to 100 when we're done. Okay. Now, variability. Think of this as the diversity in the data. We look for high variation, values represented about the same frequency. In other words, many observations in different categories. That's a high variation. And a low variation would be many observations just falling into a few categories. Highlighted caution here. Caution: variability is more than the occurrence of many different values rather than many different frequencies. So here's an example. Our charts below show the ethnic composition of two schools in the LA school system. School A has greater variability in ethnicity than School B. We described that more variability in this chart because, that's pretty obvious, there are more bars versus School B, where there are only two bars to compare. There is low variability in School B. So the fun part of the day, we're going to look at the first 5 problems from the homework. Remember that the last 5 is going to problems on the homework or problems that come from the notes, where you can refer back to the notes to get your answers for those. So question 1 is asking, it's saying there are 5 leading causes of, one second please. Yeah, 5 leading causes of preventable death in a region. They're shown in the graph to the right: high blood pressure, tobacco use, high blood glucose, physical activity, and overweight and obesity. Approximately in million, how many preventable deaths in 1 year from high blood pressure? So I would estimate this height here to be about 7.3. If you come within 0.1 decimal of the answer, you will get the answer correct. They know that you're not going to be exactly on the number. How many preventable deaths occur from tobacco use? Be about 5. I'm going to go with 5 on that. Does the graph support the theory that the greatest rate of preventable death comes from overweight and obesity, as some people have claimed? So clearly, this graph does not support that. Instead, it's high blood pressure result in more preventable deaths. So no, the graph does not support the theory that the greater number of deaths, preventable death, comes from overweight, because overweight and obesity, OO, does not cause or do not cause the greatest number of preventable deaths. Those would be drop-down bars. This graph is quite simply a Pareto chart, isn't it? It's ranked from tallest to shortest, so it's clearly a Pareto chart. The graph below shows the education of residents of two communities. Which community has the more highly educated residents? So you can see that in all of the categories except for less than high school, community B is ranking higher than community A. So clearly community B has the higher number of highly educated, because the percentages are higher. Okay, community B tends to have more highly educated because the percentages are larger than the percent in every category except the first one. Which community tends to have the least variation in education? So only community A has the least variation in education, because a substantially greater percentage are in a single category, which is the less than high school category. So the answer is obviously community A, which is answers A and C here. Now we have to pick out what the reasoning as being correct. Let's see if the answer A answers it. It says community has the least variation because a substantially greater percentage of residents are in a single category. Yes, I would go with this answer. Yeah, it can't be this one here. All right, moving right along. The survey asked its respondents to report their political party affiliation. The accompanying graphs, those are on the bottom. One is a bar chart and one is a pie chart of the same data. Part A, which political affiliation has the most men? So that would be this one, number one, number two, number three. I'm sorry, no, number three would be this one, number four, and number five, if we were rank them using a Pareto chart. So the most men would be the other category. The second largest would be strong party A. And notice I didn't even look at the pie chart. Okay. The next question, is it easier to use the pie chart or the bar chart? I would say that it's much easier to use the pie chart, because it's easier to see the heights on the bar. Yeah, so it's not this one. It's easier to use the heights of the bars. Yeah, I would go with this answer. It can be hard to determine which of the two slices on the pie here is larger if you're looking at it visually. So question 4 is asking about the projected percentage of residents in a certain country in different age categories. Complete the parts below. So to the right, you can see the graph, 2010, 2020, 2030, every 10 years projected, and the percentage by age category. The comment on the predicted age ranges from 2010 to which groups becomes at least several points higher. So notice that the group with 65 and older and over have continues to grow upwards right here. You can see that happening. This group is increasing. So 65 and over is growing. The older population is growing. Which one has become least, has at least several percentage points smaller? And that we can see that the red category here, the 25 to 64, is decreasing. And notice that the 24 and below category remains about the same across. That category remains about the same. Comment on the effect this might have on a government program that collects money from those currently working and gives it to retired people. So, the category with the older population is increasing, and the 25 to 64 category is decreasing. Now, income is going to come in from the 25 to 64 category, and that category is decreasing. So, let's look at the answers here. The money part, number one, part A, the money for the program normally comes from those in 25 to 64, a group that is increasing in percentage. No, it's not. It's actually decreasing. So we're going to have to go to the second answer. It's decreasing in percentage. And this one also has the same reasoning. So let's move on. The group receiving the money, those that are 65 and over, is increasing. Yes, increasing. So this one is out of the question, and this one is out of the question. This suggests that in the future, the government program will not be able to provide retirees enough money. And that's kind of currently what's happening in our Social Security system in the United States, where the older population is growing and the population that are actually making the money are decreasing in number. The table gives information on majors at a certain university, college. Sketch an appropriate graph to describe the distribution and comment on its important features. So look at the ranking here, this being 1 based on percentage, 2, 3, 4. So so we're looking for a graph that has social sciences the highest, humanities second highest, and math the third highest, and interdisciplinary the fourth highest. I would say that looks like graph A right here. Okay, graph A is likely going to be the one that we're looking for here. The highest category. Notice that in all of them, social sciences is the highest, so you would have to look for the second highest. The second highest would be humanities, graphs A and D would be choices, so then we would have to go to the third thing, which is math and science, and graph D has the wrong height for math and science. Remember that this graph could also be ranked from least to greatest using a Pareto chart. And of course, the mode here is the tallest one, which is what, social sciences? Yeah, social sciences. I'm going to pause this for a second. The last thing I wanted to do was to take you to the homework and show you how to create that bar chart using StatCrunch. So if I have, what is it, question 5 had the bar chart, right? Question 5. I can click on the data, click on the little button over percentage here and copy into StatCrunch. And then I want to build a graph, a bar plot using summary data. This gives us a summary. The major for, one variable counts in as percentage. And here I don't want to select order ascending. That would give me a Pareto chart. Let's select the worksheet order and compute it, and I can see my graph here, which actually matches which graph on this. Looks like this graph here. Okay, would actually match that graph on the homework. Now, if you wanted to, you can make this graph into a Pareto chart using StatCrunch by pressing Options, Edit, and instead of order by worksheet, value descending would create a Pareto chart for you instead. Oops, nope, that does not look right. Edit. So count ascending, count ascending, count descending. What am I doing? Yeah, there we go. Count descending. And that would be the Pareto chart version of this data. Okay. Remember that the last few problems on your homework are problems that you have to answer using your notes. For example, what are two commonly used graphs to display the distribution of a sample of categorical data? Bar graph and pie chart. This came directly from your notes. Okay, I'm not going to answer the rest for you. I think you guys can do that from your notes.